So everything so far, I covered, I put that in the syllabus. Okay, you should be able to find all the links, the code, and videos as well as the assignments. Okay, so I'll try to keep it very organized this semester. Okay, so Canvas is not very convenient to upload. Just putting everything in one place is a lot easier for me. All right, any question you have, feel free to stop me. So just a very quick recap, guys. We've been talking about machine learning, very basic stuff, but don't underestimate it. And because later on you will see how you actually can turn this training approach to predict the sequence of the words, because that's the foundation for the large language model we talked about last week. Okay, but probably right now you probably can already see how you can turn those text data into the table, into input data, features, and then output data, which is going to be the word. You probably can see that picture, but we're going to move closer to that stage. Okay, so very recap, guys. Any kind of machine learning problems. Okay, so these are the things you need to uh, follow. So any kind of problem, okay, first of all, you must have a very clear understanding about how the program works. So what are the important things involved, and what are the things you want to predict, you want to know, and what are the features that will be related with this target thing you want to predict. Okay, so we call it features. Okay, and normally you have multiple features, but keep in mind, it doesn't mean the more features, the better. Something called overfitting means that, you just define too many features, and then it will make a machine learning model very hard to figure out the relationship. Okay, and how do we know if that's overfitting or not? The answer is that you have to run experiments. For example, you run the experiment with 3 features, you run the experiment with 5 features and 10 features, then you compare which model actually is more accurate. Okay, so knowing the problem, define the problem with the feature and the target, that's the first step. Once you're clear about that, and then we move on to collect all the data. Okay, so very important. And we also showed you the example last week that if you don't have enough data, it's not going to be accurate. Okay, collecting data really is the key. So that's why all the major companies, they put so much efforts on getting all the data, collecting the data, logging the data. Eventually, data will just like a gas or fuel to most of the tech companies. And then once you know the problem, you have data, and it's time to train it, to learn it. In this case, you will need to understand machine learning models, approaches, how you can try to feed all the data into the target you want, right? So there are so many different algorithms, from the easy ones to more complicated ones. Today, we're going to look at some other new algorithms, but this is where the tech, the algorithm, the research comes in. All right, but again, which model is better? I mean, it depends on your experiences, but more importantly, depends on the experiments. Once you decide the model, we'll plug in that to the code and run the training. And this is normally the time-consuming part. The example we showed you last week about the traffic example, that takes like instantly. But if you're talking about large language model with gigabyte, terabytes of data, that training process probably takes a lot of servers, and then maybe it could be multiple months or up. Okay. Once you have the training done, then you don't have to spend time more and just start to use the model to apply the model to make predictions. Okay, there's 5 steps. All right. So very quick, we talk about the traffic example. This is how we define the whole problem. This is the target. This is the feature we think is related. And then we start to collect all the data. And after that, we decide that this.
Mhm.
All right. This is the linear model. And then after that, we will do the training, and then we start a prediction. Okay, so very quick recap on the code. This is what we did last time. We had a linear model. This is the input data, output data, and here's how you decide the linear model. And then this is how you do the training, and then this is how you use the data to make a prediction. Okay, and then last time I was particularly trying to show you, you have one version, and how do we make it better? How do we make it more accurate? There's really 3 things you now want to consider. Number one, you need to have enough data set. Like I showed you last time, if you don't see the data actually could come back, then you won't know the trend, right? So having enough data is really important. And then secondly, you need to actually know as I mentioned, the right features. Okay, last time we started with just the time of the day, but we know the weather is going to affect it, accident will affect it, also data week will affect it. So we showed you an example on how you can integrate other features to make it multiple dimension. All right. And then finally, if you see all of this, we also know that, oh, actually, we need to change the model. The straight line, the linear model won't work. So we need a polynomial regression, the curve. Okay, that's going to fit this problem better. But that's based on the data sample you have. So the ultimate version of the machine learning we did last week was that, yeah, so we have the multiple dimension data. We have a new algorithm that does a curve that fits the data better. And obviously with that, we also provide more data. So we do the training, you compare them, and then you can find that the second model actually works better than the first one. Okay, so that was a very quick recap on what we have so far. Okay, so any questions so far? All right. So the second assignment, okay, just try to build something similar to what we have shown you here. Okay, using regression, linear regression, or polynomial regression. Okay. So today I'm going to move on to the next one. Very important topic called classification. All right. So this is actually very simple kind of machine learning. The best example and also a very famous example is something called iris flower prediction. Okay, so if you Google iris flower data set, you can probably find this page. All right, so what happened with this problem is that this is a very classical machine learning problem, and it wasn't a machine learning problem, but it started from this biologist back in the 30s. Okay, so they did some statistics. They trying to kind of understand different types of iris data. Okay, so honestly, the iris flower I'm not too familiar with. I don't know if we've seen this one, locally, but basically it's a type of flower, and there's three types. Okay, so they're called iris. All right, and then they're called one is Sentosa, and then the other one is versicolor, and then the last one is Virginica, right? So three types of flowers, they're all like iris, but obviously you can see they look differently, different shapes, different features and attributes. So the biologists are trying to differentiate which type it is. So the only thing they did at that time was that they did a lot of statistics with the measurement. So basically, they look at all this different flowers for one type. They just do some measurement for the length and width for different parts of the flower. So if you look at the data table right here, there is where is the data set? Show you here. So this is what they did. So they recorded 150 records, the measurement, and then particularly they watch four things. Okay, they look at the sepal length, sepal width, petal length, and petal width. Again, I can't remember tell you which part is set or petal, but it's probably some part about the flower. Okay, so just some plants features. It's not our specialty, but these are just four features. Okay. And then what we're trying to predict right now is that if I know the sepal length and sepal width, and if I know the petal length and petal width, adding all of it together, how do I decide which of these three types it belongs to, right? So the biologists did this thing very simple. So they did a lot of observations and measurement, and they wrote them down. So there are 150 records, as you can see from this table, and every type they provided 50. Okay, so the first 50 records are all the first type called Sentosa. And then the second type is versicolor. And the last one is the Virginica. Okay, so let me also send this URL just in case you want to check it out, this one here. And then the data set is actually in the middle. And then every record, they have four attributes. The first one doesn't matter. The order doesn't really matter too much. The most important ones are length and width, and one for sepal, one for petal. Okay, so that is basically the data set. Now back to the step that just mentioned. This is a very, very classical machine learning problem. Okay, the problem is trying to define and decide which type the iris flower is, and then based on the four features, length and width, and we have the data set, and now we need to decide the algorithm and the training so that we can make a prediction. The goal is that in the future, if you tell me the sepal length and width and petal length and width, and then I'll tell you which type that is. Okay, so a very, very classical machine learning problem. All right, so with that, keep in mind, and let's just start to code it. Okay, so I'm going to start a new Python program. Let me actually see. I'm going to do a new one. Okay, so right? So this one I will do it iris flower example, machine learning. All right, so to follow the steps, first of all, since we have so many data, right? So we need to get the data into the code. Remember the format I told you. I normally like to write it down like input data. That's just very clear to read, and then an output data. All right, so both are list, but the difference is that the input data, because it has a multiple dimension per record, so I will use another list to write it down. Okay, so for example, I do another list, I'm going to copy this data. So the 4 attribute, I'm going to ignore the order because that doesn't matter too much. Okay, so these are the 4 measurements for the width and length, same thing as provided in the table. Okay, so to make it, we need more data, so I'm going to include a little bit more. I'll get the first 2. Right? And I still do one more. Probably just gonna use 3 for now. All right, so that's the first type, okay? So I'm gonna give a space so it's easier to see. And then I'm gonna randomly pick some record here, okay? So for the second, the versicolor. So this is 1. And then let me get one more. And then another one. All right,
Professor,
yes.
if you want, the on Wikipedia it says the whole data is included in the sklearn.dataset library, so you
Yeah,
can import all of it if you want.
that's a very good point, Sex. And then I just want everyone to see how you actually, what's the data format? Because the problem with that is that you just import everything, and then you can't see it. So, but you can print it. But I just want to give you a clear picture on how this data is organized. Yes. So you can import it from the sklearn. But yeah, let me just manually do this because you really don't need that many. All right. Yeah. So, I mean, let me try to do this a little faster. It's a little bit tedious to watch this one. All right, but very quick, 2 more record. And then just one last one. All right. Okay, so total of 9 records. Okay, so 3 types, and then for the output data, you need to put the last column there. But in general, the sklearn works with numbers. Okay, so any strings, you should try to turn that into number. In this case, easy. I'll just do 1, 2, 3. Okay, so that's pretty straightforward. And then the last one will be type 3. All right, so total of 9 rows of data. The first 3 is for the first type, and then second type, and the last 3 types. Okay, so that's how it works. Same kind of a format as I did for the traffic example. Okay, so that's the first 2 steps. I decide a problem, I get the data, and then I need to move on to the model, algorithm. Now this time I'm going to introduce a new algorithm. Okay, so instead of just always using the same linear stuff, there's a very powerful, okay, and it's really useful model. Something you must know is something called SVM. Okay. Again, I'm not a expert on math. Okay, I can't explain you too much on how this thing works in mathematically. But this is also based on the math and statistics. Okay, so the basic idea, okay, very high level idea is this. Okay, because this time think about we're trying to classify, right, the flowers, right, 1 or 2 or 3. Okay, now if you put them on the same kind of a 2D plane, and then what we want to do is to group them together. Okay, so but from mathematical point of view, you can still define some kind of function. Okay, you put the line here, right? Assume it's still a linear kind of function, and I m and b. So if you give me an X and Y, or if you give me an X, I give you the Y, so I give you a position. Based on the position, if it's below the line, you probably belong to this type. If it's above the line, you belong to the other type. All right, so that's what SVM is trying to do. SVM is not trying to just predict a simple like Y, but also they're trying to predict which category you belong to. But then the trick is that for SVM, the line where you're drawing the line matters. Now, obviously, the red line is the best line you can see, and blue line also works, and then the green line is not working very well because you can see the green line, it kind of mix this some of the parts of the dot together. Now, the blue and the red one, you probably will see that the red is better because you can see the red line actually split this two group of data a lot more effectively. Where the blue line, it does perfectly split all the two groups of the data, but it's a little bit too close, right, to some of the points. And that's going to make you a little bit nervous, okay, because you never know next point if it's going to get too close or there's some overlaps. Where the red line, actually, I give you a lot of a buffer and space for you to classify these two group of points, okay. But anyway, the SVM model, if you decide to use that, it's trying to give you this kind of lines that can split your data into different groups. And then SVM model will, by training it, it will actually get the perfect line here. Okay, we'll come back to this algorithm a little bit later, but that's how the SVM works from the serial point of view. Okay, but specific how it works, guys, this is all of my knowledge. Okay, so there's quite a lot of calculus stuff. That's why if you want to get into the research part of machine learning, math will become actually very important. Math and statistics. Okay, but if you just focus on applying the algorithms, it's fun. Okay, so don't worry too much to say, oh, I'm not very good at the math, especially the advanced one. Some of the math courses are getting very complicated in the college level, so it's okay. All right, so you really don't have to understand all of this in order to use this, as long as you know the feature, the most important parameters you need to configure, and then just run an experiment to see how it works. Okay, so but anyways, SVM model is really good at doing this kind of classification examples, and then it's normally the accuracy is really good. Okay, it's one of the best ones. So you have to know this one. Okay, there's so many models. I would definitely point out this one is something you can use very often. Okay. All right. Anyway, so based on that, we can go to the code, and I'm gonna use that model called SVM. Okay, for this problem. Now, as normal, we have to import it. So from sklearn and import something called, I think it's called SVC as part of the model. Okay, that's how it works. And then from there, we can then define a model, which is SVC dot, I think then it's SVM. All right, let me make sure this is correct. Okay, let me run this code so that it start to automatically do the pip install in the library. Wait, might be the SVM. Okay, I might be wrong. Okay, so let me go. Provide a hello world example for SVM training using scikit-learn. Yeah, I think I might reverse the keywords. Yeah, so they do the SVM. All right, so let me go back here. So should be the SVM, and then this is SVM and SVC. Okay, that's how it works. All right. So let me try to redo it. All right, this one should be working. All right, so SVM. All right, so the SVM is just a package or the class, and SVC is the actual class that specify or implements the algorithm. Doesn't matter. So it's just a naming convention, but the algorithm is something called SVM. Support vector machine. Okay, so all right, but again, no need to understand too much about the algorithm details. It's worse in the same way as linear regression. It's just the math is different. All right. Once you decide the algorithm, next step, okay, do the training. Now, training the sklearn is always the same. Model.fit. Okay, they use the same interface. You just provide the input data and output data. All right. And again, this is the magical line of code. That's all the complicated work. Once you have that, you can start to make a prediction. Okay, let's actually run the code and make sure the training can be finished. All right, looks good. Now let's make a prediction. So model.predict. And remember using the same format. I'm going to predict, see if, you know, just in case you see another flower on the street, you do the measurement. And in this case, I'm going to just go to pick some random numbers we didn't see before. So for example, I'm going to go use this one, which is the first type. Okay. So I'll put it in the code. And just like this. All right. And then I'm going to print the result. Let's see. Run the example again. All right, so the result is 1. Okay, the first type, which is correct because I'm actually grabbing this number from the very first type right here. Okay, so let's do some more tests. I'm going to do another one, probably the second type here. Okay, I'll just put it afterwards. Okay. And then let me also do one more for the last one. Okay, try it again. So we have 3 test data to run. They're supposed to be 1, 2, and 3. All right, so that's how it works. Exact 1, 2, 3. As you can see, the model is very accurate, even though I only used 9 input data, okay, for my data set. However, if you see the data set, you know, it's pretty clear that they have some kind of pattern. As you can see, the first type, the last 2 numbers tend to be a lot smaller. And these 2, and if you try to see, looks like the second and the fourth column is smaller than this one. So that's how the machine learning works, guys. I think this probably is a better example that even though you don't know too much about the domain, but if I gave you complete data that shows all the features, okay, and that's going to give you some good results. Give me 1 second. But then what the machine learning is trying to help us is that we don't have to figure out what's the relationship there. Okay. The algorithm, the model, they will just follow the math and then do that for us. All right. So if I gave you this kind of data, you probably can write a bunch of if-else statement to give me the same results. But it's going to take way longer than what the machine learning can do. And then also the accuracy is not really guaranteed if we do ourselves. Okay. So just another very famous, very useful, but still very simple example of machine learning. And again, look at the code. Okay, so it's 1, 2, 3, 4, 5, 6. Exactly, just 6 lines of code. You can do a machine learning problem. Okay, but you should know behind it, it's really complicated. Okay, now actually in the large language model context, the flow of the code is actually exactly the same. Okay, obviously you can't do that with 6 lines of code, but then if you look at a high level, they pretty much follow the same thing. And this part, they probably have a lot more data, and the algorithms is way more complicated, and the training takes longer, but the flow is the same. So that's why I keep going back to this slide here. If you master these steps, you literally can solve any kind of machine learning problem. So whenever you see the data scientist, machine learning positions, don't be intimidated, okay? You might feel, oh yeah, the machine learning model is very complicated, but then the truth is that uh, almost no developer understand this, okay? And so all we need to know is to abstract the problem, define the problem, and knowing how to try different algorithm to compare which one was better. And that's what the data science is trying to do. Okay. So technically it's fine because most of the challenging work is taken care of by the libraries. All right. So this is just another example on the iris flower example, which is a very famous example you will see in a lot of courses. Okay. Any questions so far, guys? All right. So if this looks very clear, okay. Now, first of all, I want to go back this algorithm a little bit. Now, hopefully this one right now makes a little bit more sense that the way they do this is, as I mentioned earlier, that SVM still trying to get you a function with a straight line or curved line that, we don't care, but it's some kind of a line that can help us to split the data into different areas. Okay. Now I was trying to tell you that the blue line and the red line both work, right? But we said the red line is better because of the spaces, right? So you feel a lot safer when you try to group them. And from a mathematical point of view, what you're trying to do is that you should count the margin between the lines and to every point. So you want to maximize the margin, the average margin. So that's why the blue line is not good because the margin, some of the margin is very, very small, where the red line gives you the maximum margin. This is actually the opposite of linear regression. Linear regression, they're trying to get the line as close as all the points to reduce the margins, right? So that's called the best fitting. But as you can see, these are two different kind of algorithms and using different purposes, right? So with that, I want to ask you this question because today I was telling you that we'd go through this machine learning problem, which is the classification. All right. Now, can anyone summarize, okay, the differences between this iris example you see here and the traffic example we did last week? Now, obviously the algorithm we use are different, but can you guys tell me some more difference you see between the two type of machine learning problems? It can be anything.
I think in the traffic one,
Mm-hmm.
we were trying to create a model that we have like a line that's closest to where the points are.
Yes.
So you can see like a best fit line. And
Yes.
this one, we're kind of trying to make a line where we can divide the clusters into different sections.
Yes. Yes.
So in the first one, you would see how close is it to the line, and you'd use the line to predict. And this
Uh-huh.
one, you would see on which side of the line it is, and then you can predict which one it is.
Yep, yep. Very good, Danny. Yeah, thanks for the answer. That's what I was trying to show you, the graphs and SVM. That's how it works. And then the linear regression. I don't know if I can find a line, but yeah, so they're trying to get uh they're trying to get the things to fit into all the points. All right. So that's one. That's how you can, that's the differences from the shape or the model itself. What other things you can summarize in terms of differences between the two problems? They all have to, define the table. That part is the same. But besides the algorithm is different. What else? Anything. Yeah,
Well,
even
for this one, you're
yeah,
trying to predict what class certain data belongs to, as opposed to the linear regression one, where you're trying to predict a value that's not necessarily associated with a class.
very good. Yeah, very good. That's the answer. That really fundamentally differentiate the two. Okay, so very good answer. So what to clarify that? Okay, so this is what Danny mentioned. Okay, so let me actually show this one here. Just from the algorithm, you can see the regression. We do the best fitting, and then we're trying to get closer to the points where the classification, the thing we did today is trying to split them. Okay, we should let them to be away from each other as much as we can. Okay, but that's what you see from the mass point of view. But Cleo just mentioned something more fundamental, which is that if you think about regression, okay, we're trying to predict the traffic. Now, if we go back here, we're trying to say, oh, 11 o'clock, the traffic will be 8, and 12 o'clock will be 9. And if I ask you like 11:30, so you probably will tell me it's 8.5. I ask you like 10, 33, and you tell me something like 7.33, something like that. So you're always getting some kind of a specific or concrete value from the linear regression model or polymodel regression model. So you're doing really a math calculation based on that formula. Where the iris flower example, okay, so you're not gonna get that many numbers. I don't know if you see that. It had to be either 1 or 2 or 3. You can't give me a 1.5 or 2.3. It doesn't make any sense. And then you cannot really tell me it's a 4 or 5 or 0. We don't want to see that. And all we want to know is that which type that is. All right. So this is a fundamental difference between something called regression and classification. So I told you the topic for today, classification, earlier, but you didn't realize it's actually a different type. This table summarizes. Okay, so the regression is trying to predict continuous quality, where the classification trying to predict the class label. Okay, which label I should give you. I can't give you some kind of a number in the middle. It doesn't make any sense. All right, that's the fundamental difference. All right, so because you really need to understand this, because all the machine learning problems, okay, you probably can put into one of these tools. So for example, we talk about like the self-driving. And then they do all the computer vision stuff, right? So they take a picture and they try to figure out, if this is a car, and if that's a car, where that is. Okay, is that a to figure out the object here in the image? Is that a regression or is it a classification?
Classification.
Yeah, it is a classification because you have to tell me which type it is. There are only certain number of objects we can recognize in the world. Okay, so you need to tell me which one it is. It's a car, it's a traffic sign, it's a person, or something else, right? Classification. All right. And then if you're trying to predict that in the past year, some of the students, what kind of project trying to predict our parking lot spots at different points, different time of the day. That is obviously very similar to the traffic. It's also a regression because you have to tell me how many spots there are and give me a number. Okay, so really keep that in mind. Okay, but if you understand that, if we're thinking about the large language model, okay, back to that example we mentioned earlier last week, that the large language model always trying to do is to base on some kind of input sequence of words and predict the next word. So in that case, which algorithm you think, which machine learning it should be? To clarify the question, so going back to the large language model prediction and training, okay, I gave you some input sentences, and then you tell me what is the next word based on that input sentence. Is that a classification or is that a regression?
That'd be a regression problem.
Why is that, David?
Trying to predict something. Uh, like you're trying to predict something that doesn't necessarily fall in a category,
Uh-huh.
some continuous variable.
Continuous variable. Okay. Yeah. That I mean, the reason you said that is because you probably feel there's just so many words and characters and tokens. But on the other hand, there are always limited number of words. If you're trying to predict English, okay, the words are limited, and the ChatGPT is not gonna give you a word that never exists, right? So to that extent, I think it's probably easier to understand it like a classification problem, because your dictionary is fixed, okay, or your tokens are fixed. There might be a lot, but but it's fixed. So I give you a sentence, you have to tell me one of the words. Okay, I'm asking an English sentence. You can't just give me, if you give me like a something not from this vocabulary, like a Chinese character, that's not very good prediction. So I would probably leaning toward to put this more like a classification example. Although the actual case is probably more complicated. But to simplify that problem, okay, I think the classification problem probably it's easier for us to abstract the you know the data set, and then so that when you try to read the algorithm, you probably can have a better way to do it. Okay, so but you know that's I mean either way is fine. You can also say that based on some of the continuous value, and I probably will do some different kind of tokens or words, you know, probably depend on the algorithm, right? So I think either way works, but if you want to simplify the problem, I think the classification probably is just easier to understand. Okay, just pick one of the words from the vocabulary and show it. All right. But yeah, anyway, so in the future, you will actually see all these kind of problems using machine learning. If you go to Kaggle, all right, the website that does all this you know, data science problems. There's just so many examples you can see, but any of those you can probably try to you know, figure out the you know, the answer. So this one is like F1 championship data set, and so I don't know what's inside here. Okay, but you can take a look at a lot of this. So they tell you all the, probably they give you all the years of you know, games, the location, and latitude, longitude. They tell you, oh, the Wikipedia page, which probably has more things. Oh, they have results. Okay, so based on this, you can probably try to predict the result for different teams, different players, and yeah. So that depending on what you want. Okay, you want a ranking, probably that's better for regression, because you know, it's a probably a continuous number. But if you want to predict the team, I guess maybe the classification makes more sense. All right, but yeah, keep that in mind. Now there's a one more thing called a clustering. So we will not try to cover it, but I will just briefly mention that. Okay, when we talk about a clustering, normally that's the third type of machine learning. The clustering is almost the same as a classification. Okay, you're still trying to do the class, but the difference is that you don't have to label it. Okay, so for example, for the iris flower example, we actually told them these are the you know, the first type, and these are the second type, and these are the third type. So in the training data set, you actually specify, you tell the machine, that's how you define the data set. But sometimes you either don't have that label, you don't know, so or you just don't want to define it because there are too many. So in this case, you could use something called a clustering, which means I just gave you all the input data. Now I want you to divide it into 3 types. You do the job. I don't care how you define it. As long as you think they're from the same group, then you do it. So they will automatically turn those numbers into 3 classes. Okay, but you can also say 4 classes or 5. Okay, so that algorithm we call it clustering. Okay, but this is probably not very useful in large language model because you really need to label those. Okay, you have to tell them what's the right way to write some sentences. So I will not cover this too much, but you know, essentially this is also a classification problem. But for the data sets, you don't have to label them, and that's why there's another term called a supervised learning. Supervised learning means that when you providing the input data, you actually label them. You supervise the algorithm. These are the correct predictions, and then try to figure out the relationship. There's another thing called unsupervised learning. I don't give you the answer. I don't give you the label, or you figure it out yourself. Okay, so that's what the classroom is trying to do. All right, but these are just the most fundamental concept. But all you need to understand is how the regression works as well as the classification works. All right, so but most of these things I talk about, if you took any of the online machine learning courses, you can probably just learn the same thing. But I just condense everything and give you the easiest version of it. All right. So yeah, that's classification algorithm. Now the next thing I want to do, I'm gonna get started just a little bit, and I will leave the rest to you as a kind of a homework. Okay, so what I want you to do today is I want you to get some hands-on exercises. Okay, so this is one of my favorite example to do for machine learning. So I'm gonna do something for the rock paper scissors example. All right, so now you can always write this algorithm to do to write a Python code to do a very simple terminal-based rock, paper, scissors game that you play with computers, okay? So the task is how could you turn this into a machine learning problem so the machine can learn how the player plays, okay? So I'm gonna get the very basic code framework there, and that way you can start to think about how you can use machine learning to write a better player. Okay, so rock, paper, scissors. Okay, very simple. So you have the player that gonna input your choices from the terminal, and the computer will do just some kind of strategy. Okay, so I'm gonna do something. Oh, so the capital. So player voice. Okay, so we're gonna do the input. Now please make a choice. I guess I'll make it easier. So I will do the numbers. So 1 is rock, 2 is paper, 3 is scissors. All right. And then, so this one, I will also turn that into integer because otherwise it's a string. Okay, so it's 1, 2, 3. All right. Now the computer choice, I can do a random for now. All right. That way you can start to check. So if the player choice equal to 1 and the computer choice equal to okay, so we're gonna do this rules. This is the rock, and if I do paper, okay, so we're gonna say that you lose. Okay, the human player lose. All right, so but there are other cases. Okay, let's just finish all of them. So player choice, if that one equals to 2, and the computer does if a paper, I do scissors, and you also lose. Or if you do scissors, but I do a rock, and you still lose. So these are all the losing situation, right? Otherwise, I'm gonna check, just reverse this for the winning situation. All right, so I'm gonna reverse this 2 and 1. And this one will be 3 and 2. Then this is 1 and 3. All right. Otherwise, it's a tie. All right. So that's how it works. Yeah, let's actually test it. Okay, so I'm gonna run the program. So I'll do a rock. Or let's actually also print out the computer choice. All right, it's a tie. And then let's actually make it more round. I'm gonna do paper. And they also do paper. I do like, oh wait, there's something wrong. Why they're all the same? Your choice, it's random. All right, it's probably just coincidence. Okay, I do 3. So I choose scissors, and then the computer choose rock, so I lose. And if I do rock, all right, now I win. Yeah, looks like it's working. All right, very simple program. Everyone should be able to write this. Okay, but now this computer isn't very intelligent. Okay, so they use a random, okay, which is fun for this game, but you're gonna get 30% chance of winning, right? So we want you to think about how you can use machine learning and try to write the algorithm for a computer. Okay, we're trying to improve the computer's strategy. Okay, so this code doesn't look very good. Okay, let me see how I can. Is that this gonna work? Do I need to add the other ones in here? Okay, yeah. So let me break the line. Okay, otherwise it looks very bad. Okay, so make sure this one still works. All right. So a very simple program. Okay, so that's what I want you to do is that I'm gonna write a code. I probably will leave this one to you for you guys today to do a little exercise. Okay. So let's not use the random strategy. Instead, can we do we try to learn how the human players plays, and so that we can detect if there are any kind of patterns. So think about when you guys are playing the rock, paper, scissors. Okay, most of the time we probably do it very randomly. But you never know. Sometimes you might start to have some kind of your preferences, whether you are aware of that or not. So some people probably shows more rocks. Some people just like to do like papers in a row and then switch. Or you just want to do something repeated for 2 or 3 times and then you switch, right? So everyone will have your own strategy. So I feel it's not totally random. So if you ever play this one, you kind of understand what I'm talking about, right? So it's just a matter of whether you thought about the strategy or not. But at the end, probably you're not doing this totally random. Okay. So if you agree with that assumption, when you are building the computer choices, okay, you can probably trying to predict what the human players is trying to show up next. Okay. If I kind of start to play with you for a few rounds, I find, oh, actually, you often like to do the rock followed by the paper. And if I see next time you do another 2 rocks, I'm gonna predict next time you're gonna do a paper. And in that case, I can improve my choice here. And then I'm gonna do a scissors. I'm trying to win you. Okay, so that is a little like a machine learning thing you can play. But you might be arguing, that's not my style, whatever, but that's okay. So for any kind of problem, you must have a hypothesis. Okay, so like just like the iris flowers. So we believe these types are determined by the sepal and petal width and length. Okay, now in this case, my question for you guys is that assume that the players often will have some kind of pattern based on the sequence, based on the past choices they made. How can you make a machine learning model with it? All right, I don't know if I describe the algorithm or the idea clearly. Does anyone have any thoughts on how do you turn this into a machine learning problem? First of all, is that a regression problem or it's a classification problem? And also, how would you define the features, the input data and output data?
Can we do a kind of a cluster model where we see like what they're most likely to choose?
Most
So we
likely.
see like
Uh,
we get like a bunch of data of what they chose in the past,
Yeah.
and then the biggest cluster is what they're most likely to choose if this is like the first time they're playing, or
Okay.
if like the biggest cluster is like paper, they're most likely to choose paper, so we might as well choose scissors
Okay. Well, let's follow
because
this.
they have a preference in that.
Yeah. Let's follow the steps. Okay. So first of all, um, let's define a problem. Okay, the table. Okay. So what is the target you're trying to predict, and then what is the input feature that's going to affect it?
I'm just trying to predict their most likely choice.
Yes. Okay. So the next choice. Very good. So what will be the values for this one?
It's either 1, 2, or 3, or 0, 1, 2.
All right. So that's what we're going to try to predict. That's the target. Okay. Very good. So then how are we going to, decide the features? What are the things that are going to affect this one?
Just the previous choices.
Previous choice.
Yeah.
Very good. Which is also 1, 2, and 3. Very good. All right. So that is one model. So, that's basically like what I mentioned earlier. I often try to remember what you did last time. And then I believe your next choice somehow will follow some pattern based on the previous choice, whether it's the same or you rotate or you go with some of your own ways. And we're trying to learn that pattern. So very good. Okay. So now with that, let's assume, okay, so I'll give you an example that, for example, my play is like I like to do the rock, and then I will do a scissors. I do rock, scissors. Just assume that this is my strategy, or at least that's what you see how I play. Okay. And then in that case, how can I, well, I don't even ask. So, it's going to be very easy to plug in the data into the table, right? So first time I do 1, so that's going to be here. And then next time, once I done, you saw actually I did another one. So this should be the first data set or the record. So next time I do a 3, so then you will know previously you did a 1 and then you actually show us 3. Okay. And the next one is going to be 3 and 1. And next one will be 1 and 1. And then keep going. Okay. So basically the more you watched, the more data set you will have, and then the stronger the pattern you will see. So the machine learning model probably can pick it up. All right. But Danny, you were telling me about the clustering. Why do you think about the clustering?
I just figured because if there is no pattern, let's say that at each time it is like almost random. If we have like maybe 100 values and
Mhm.
we don't know what they chose before, but we just know like they played 100 games and this is what they chose the most.
Okay.
So we kind of like can see if they have like some kind of inherent bias to choose something more than a different choice.
Yeah, I see your point. But I don't think the clustering will work for this case because the clustering only trying to do 3. They're trying to give you the 3 groups, but then they do the classification. But you have to decide for each group what does that mean.
Mhm.
Right. Then that way you can know the strategy, because if I predict I gave you it's a 3, that means you're gonna choose the scissors. Then you probably know, okay, I'm gonna do the rock. But if you only do the classroom, they only tell you 3 groups, and you still have to decide or write another statement to say, oh, this group means this group means this. So that's why, and also in this case, because the data the target you can already learn it, right? It's very easy because it's already showing you in the sequence. So
Yeah.
you should actually provide the data as a supervised learning model, which will give the machine learning model much more accurate results. So that's why the clustering model, I don't want to talk too much. It looks very cool, right? So you don't have to worry about anything, they just do it. But they're obviously they're the trade-off. Because if you don't even tell a machine what they're looking for, I mean, machine is a machine. No, you can't expect the machine to tell you exactly the type of class you're looking for. So if you can do supervised learning, machine learning, I would go with supervised. That's why you probably seen some stories that the way the ChatGPT can be so well is their, part of the reason is their data set is so good. But this is huge, and
Mhm.
getting the data set isn't hard. You can do the web scraping. You can download all the data from the internet. But the challenging part is supervise the process. And you can see some of the news that they hire a lot of people, especially from some of the developing countries. They hire the low cost, low salary people to do the manual work, to kind of label them. That's really a tedious process, but that's actually very important. Okay, that your basic supervised machine, how data should work. So anyway, back to this case, guys. I want you to use supervised machine learning or a classification, because this is the clear classification problem. You don't want to tell 1.5, 2.5, just tell me 1, 2, 3, and what are the choices. And this model I'm telling here is based on a very simple observation based on the previous choice. Okay, so I'll call this version 1. Okay. Now, if you want to like make a little bit more complicated, okay, you see that this guy is like always think very complicated. Okay, they want to do like a multiple rounds. So you can even go the previous 2 choices. Okay, you want to see the past 2 games, how they play, and then you make a prediction. Okay, just assume, just like this. Very often, if you see I do 2 ones, you're gonna see a 3. If I do 2 ones, you're gonna see a 3. All right. So in that case, when you try to put this model, well, this is what you put: 1, 1, 3, and then 1, 3, 1, and then 3, 1, 1, and then 1, 1, 3 coming back. Okay. So, which means that you have to see enough 3 games in order to start to put the records on, because otherwise you don't have enough data. But once you have the 3rd game done, and you can see what they did, and you can put into 1 record. And then the 4th round, you can see the past 2, and then see this next choice. All right, and obviously you can do other versions. You can do even more complicated. Okay, so 3 rounds in a row or more. Okay, so that's just a 2 model you can do. All right, but I want to use this example to first of all to let you to try how the classification works and how do you actually really apply this into practice. I like rock paper scissors example because it's not like a very like a traditional like iris per flower. I give you data, you just train it. That simple. And this one you have to do some of your own logic. Okay, so anyway, I'm gonna use this one as a next assignment. Okay, so I'll write down the assignment, but for now I can just give you this code right here, or you can just create your own. It doesn't matter. You don't have to follow mine. Okay, so this is a very simple code. But what you need to change is that I don't want you to do the random choice strategy. You need to write a logic to record how the user plays. And then every round, you will need to add the data to your machine learning model and to retrain your model, and then use that to predict next choice. So this one, you probably want to do a better one. So I'm going to define a function. I'll call it get next choice. Okay. So what this is going to do is to update the latest human player choice records, retrain the model, and predict the next human player choice. And based on that, show your best next choice. Okay, so I want you to change this one to this algorithm. Okay, instead of doing this, I want you to do get next choice. All right. So you will need to implement this algorithm, but feel free to make changes here as well. Okay, so you probably want to, every time you actually record a choice, and then you have to, maintain the history and then train it. All right. So I don't know how you feel about this little assignments. Okay, it seemed to be, it's not difficult at all. Okay, it basically just use SVM model. Okay, just use SVM model. Okay, this is gonna be good enough. All right. And then yeah, but then you need to think about to define the problem, like I mentioned earlier here in the slides, and constantly adding the data to the table as you play. Okay. The goal is that if you start to play like this, guys, I want to show you, okay. The end goal, if your program works, if you do a kind of pattern, oh, sorry, this one here right now is just, I'll just do a random first, okay. So right now, if I do 1, 1, 3, 1, 1, 3, it's totally like random. Okay, so you can lose, win, win, lose. I do 1, 1, 3, 1, 1, 3. It's all random. I can still win. Okay, so that's what's going on right now with the random. It's equal probability. But if you implement that machine learning problem correctly, okay, if I still do this 1, 1, 3, after a few rounds, I should always losing because you can already predict I'm gonna do 1, 1, 3, 1, 1, 3. Okay, I should always see losing. That means your machine learning actually pick up the the records and the pattern. All right. Does this example make sense, guys? Any questions? I'm not gonna finish this class. Okay, I'm gonna leave this one to you as the next small assignment. Okay, let me know if you have a question right now. One more time, okay? Don't forget these are the data model you could use. Whether you use one choice, I suggest you do two choices because one is a little bit harder to figure out the pattern. Let's actually start with this one. That give you enough like input for you to make the next choice. Okay, probably use this one is better. But I want you to constantly updating the model, okay? Because as you play more games, that's how you can figure out a pattern. You can't just dump into some existing data set. You never know, okay? So don't assume this one's just an example, okay? You can't just give me a fixed data set. You have to do this dynamically in the code. All right, so that's your next step. I don't know if you guys can see it. The reason I want you to work on this example is because now see all this with this, the table, actually, it's very similar to that sequence example. Okay, we keep talking about large language model to predict the next word based on the previous sequence. See, this is a sequence, and that's the next choice. So if you know how to do this, well, the large language model pretty much works the same way. Okay, so that's why I want you to go through all the way from the basic machine learning to this point about classification, because if you can do this, you will know how to predict a sequence. All right, so this assignment is very important. Actually, the other assignment is also very important, guys. Okay, all the things I'm talking about are super, super practical. Okay, if you go start working in a company, anytime they give you a machine learning task, they're not gonna let you design a new like a neural network algorithm. Okay, that's impossible. Okay, very likely you're gonna use a very basic, a very popular, famous that the algorithm that's already been proven very effective as SVM. Okay, to solve the very common problems. Okay, you don't need to do another like a master's degree to learn all of it. No, so it's just a very simple. Okay, so it's more like a hands-on, try it, see the performance, accuracy, and you decide which one is better. Okay, so I'm gonna stop here, guys. Do this as assignment. Okay, finish this one by next class. Okay, it's a very fun task to do. But one more time, any question, any classification, clarification you need? Sorry, Danny, I can't hear you. Uh,
Do we only have to do one is the version 1 or version 2?
yeah, I would suggest you if you start from version 2, okay? Because the version 1 you might not see a very good results because it's just one, right? So version 2 probably is better.
Okay.
Professor,
Yes, Darren.
could you also like post like maybe like a small like task or like an announcement or whatever of like what you want us to do so we can come back and
Oh
look at
yeah,
it?
yeah. I'll need to write down. Yeah, I write down a description for this. Okay, as a formal assignment,
Perfect.
just right after
Perfect.
the
Cool.
class. Yeah, because
And oh,
yeah.
sorry, sorry.
Go ahead. Go ahead.
I just had also another question for the assignment that's also due, assignment 2. For the 2 lines, do they have to be like one line is like linear and another line is like completely like all over the place, or how does it have to look?
No. So you I think we were asking you to one, you do the linear regression. The other
Yeah.
one, let's use the polynomial regression.
Oh, okay, got it, got it, got it.
Because that way you can compare which one was better.
Okay, got it, got it, got it. Okay, cool, cool, cool.
It doesn't matter how good or bad the result is. We just want you to know you can actually try 2 models so you can see the differences.
So one linear regression, one polynomial regression, pretty
Yes,
much.
yes,
Got
yeah,
it.
yeah. Of course, feel free to explore other regression algorithms. There are a lot of a very famous one, something called a logistic regression. That's
Okay,
also worth to look into.
perfect, perfect, cool. Thank you so much.
Yeah, no problem, guys. All right, so I'm gonna stop here, guys. Again, I'll put a recording, everything. This one, it's gonna take some time. Okay, you gotta try to figure out my logic. Okay, so the code isn't difficult, but think about what are we trying to do, how the machine learning can help here. Again, follow the 5 steps, define the model. The only thing different this one is that you have to real time update your data set. Okay, and it's not a fixed data. It's updating the data set, retrain it every time, and then make a prediction. All right, so it's gonna be a lot of fun, guys. Next time, let's try to finish it. Okay, so next class is Thursday. Yeah, let's try to get a version on Thursday. Okay, so I can give you some extension if you want, but ideally you should try to finish it by Thursday. I might want to pick some of the versions so that you guys can, you can you don't have to do the 2 step. You can do other ways. Okay, I might try to pick 2 version, like let you guys to play like a simulation to see whose algorithm is better. Okay, so yeah, I'll make a submission. Okay, next class I can probably figure out some of your methods to put them together and to run some kind of competition. All right, yeah. So yeah, so if you don't have questions, I will see you then on Thursday. Okay, so oh, by the way,